See this problem. Three identical metal plates, each of area A, are arranged parallel to each other. D is the distance between the plates as shown. A battery of V volts is connected as shown. Find the charge stored in the system of plates. So first of all, our motto, we need to find our motto. There is a system is given, like a system of capacitors, a circuit of capacitors. So for that system we need to find out the total charge deposited on that system. So Q, we need to find out total effective charge, we need to find out. That is our motto. So look at this, there is a battery which is connected to some plates. So on the plates the charge is depositing like this. So that charge we need to find out. That is our motto. Now I am investigating what type of quantities that are given. So the area of the plate is given. Each plate area is equal to A, and the distance between the plates is given, that is D, and the potential difference that is connected to the circuit is given, that is V. So we need to find out Q. Now I am resolving the problem and as well as the circuit also. If you see the circuit clearly, three plates are like this and each are separated by a distance D and connected to a battery like this. Now I am writing a simple thing. I am taking the ends of the plates, I am numbering the ends of the plates, sides of the plates. For example, 1, 2, 3, 4, 5 and 6. So if you see this, 3, 4 are connected, seems to be connected commonly to a negative end of the battery. So slightly I am changing the drawing. So I have a plate like this and another plate like this, and I am connecting these two, and this is connected to a negative end of the battery. Look at this carefully, negative end of the battery. There is no change if I draw like this also, because anyway the 3, 4 ends are having negative charges like this by connecting with the negative end of the battery. Just I am separating the faces, that's all. There is no change in the charge if I separate these two plates. There won't be a change, because the remaining things, the things which I have connected with the negative end is a conductor. So if you separate the plates also, there is no change, we don't get any change there. So this is third end, this is fourth end. So opposite to third end we have plate like second plate, that is 2, 1, which is connected to a positive end of the battery, and for the phase 4, opposite to that phase 4 you have fifth phase of the another plate and sixth plate as well as, and it is also connected to a positive end of the battery. So if you see, there are two capacitors which are connected in parallel with a battery like this. It seems to be like this. It means those two are connected in parallel. So if the for the combination of parallel capacitor for the combination of capacitors in terms of parallel thing, then we have a effective capacitance C is equal to C1 plus C2. This is the effective capacitance for the capacitors which are connected in parallel combination. C1 in the sense capacitance of first plate. So here the distance between two plates is D and the area of the capacitor plate is A, then each capacitance is equal to epsilon naught A by D plus another capacitor also having same dimensions, so you have epsilon naught A by D, that is equal to 2 epsilon naught A by D is the total capacitance of the system. Then what is the charge on the system? Charge Q is equal to CV. We already know this problem, that is equal to C 2 epsilon naught A by D into V. So that is the whole charge deposited on the system is 2 epsilon naught AV by D.